Okay, here's just an example that I'm going to give you on how you're going to complete the quantitative reasoning assessment. Just these are the kind of things I'm looking for in order for you to receive full credit for this assessment. So our question says the company XYZ knows that replacement times for the quartz timepieces it produces are normally distributed with a mean of 12.3 years and a standard deviation of 1.2. So this is going to be my population mean mu and my population standard deviation sigma. Question 1 says find the probability that a randomly selected quartz timepiece will have a replacement time less than 8.9 years. Question 2 says if the company wants to provide a warranty so that only 3.6% of the quartz timepieces will be replaced before the warranty expires, what is the time length of the warranty? So we're going to use the space provided below to show all of our work that justifies our answers. And if we need extra paper, we can do so. So I'm going to put my work for question 1 right here. So it helps to draw a normal curve just so you can kind of see what we're looking at. So I'm just going to draw my normal curve with this mu and this sigma. So we'll draw our curve. Something like that. My mu is 12.3, I believe. And my sigma, I'm just going to draw this off to the side. Sigma is going to be 1.2. Okay, so I'm looking for the probability that a timepiece will last less than 8.9 years. So if I write that out with a probability statement, that will be the probability that a randomly selected timepiece, X, is less than 8.9 years. Okay, so that's the same thing as saying if I put 8.9 on my curve, let's just put it somewhere out here. We know it has to be less than 12.3, so we'll put it to the left. I'm looking for the area less than that. Okay, that's the same question mathematically. So to do that, I'm going to use the z-score formula because the first thing I have to find is the z-score. So using this formula, I get z equals 8.9 minus 12.3 divided by 1.2. And I get a value for z of, let's see, clear this out. I have 8.9 minus 12.3, and we will divide that by divide that by 1.2, sorry. We get negative 2.83 repeating, but we'll only use two decimals, negative 2.83. That's a z-score. So in order to convert that to this area, I'm going to use the z-table. So that's located on our Blackboard page under Course Materials, Unit 3. So I pulled it up right here. So I'm on the negative side. I'm looking up negative 2.83. Here's negative 2.8. Here's the 300th place. So I'm looking for where this column and that row intersect. And that is going to be my area, 0.0023. So the area of this little section is 0.0023. So if you wanted to write it as a probability, that's fine. You can leave it like that, 0.0023. Or if you prefer percentages, you could write this as 0.23%. Okay. Now the next question says the company wants to provide a warranty so that only 3.6% of the quartz timepieces will be replaced before that time. What is the length of the warranty? So let's put that work down here. I'm going to draw the curve again. It's going to look the same except for a few small differences. So I still have my mean in the middle, 12.3. But now I'm looking for the value of x. We'll just call this x here. That cuts off the bottom 3.6%. But I'm going to use a decimal here, which would be 0.036. Okay, so I have the area now. And I'm looking for the value that cuts off that area. So it's kind of the same process we did for part 1, but completely backwards. So the last thing we did in part 1 was use the z-table to find the percentage given the z-score. Now I'm going to use the table and the percentage to find the z-score. So going back to my z-table, I'm going to look up the area of 0.036, or as close as I can get to that. 0.036. They do kind of go in order. So here's 0.01, 0.02, 0.033, and we keep going. It looks like this is really close to 0.036. It's 0.0359. So that's basically right on. So we can use this z-score of negative 1.80. So my z-score is going to be negative 1.80 or negative 1.8. It's up to you. Now I'm going to use the same z-score formula to find x. But now I have z. Negative 1.80 equals x minus 12.3 divided by 1.2. So I'm going to solve this for x. I'm going to multiply negative 1.8 times 1.2. And I have negative 2.16 equals x minus 12.3. Add 12.3 to both sides. And I get an x value of 10.14. Okay, so we have x equals 10.14, and we're going to use years. Okay, and that will give you sufficient work to get full credit for this assessment.